Okay, do you want to start? Okay, so the first question is, anyone knows who this gentleman is? No.
The white European
philosopher. Okay, so this is David. Do you know who this gentleman is?
אולי תחווה את האור. שמפוניון?
שמפוניון.
לא, שטופניון. Chateaubriand, Champollion.
No. This is Alexander Pushkin.
Oh, Pushkin.
Okay, and the reason, Alexander Pushkin wrote a very famous epic story in verse. It's called Yevgeny Onegin. Some of you may have heard about it. The reason is relevant. The only reason is relevant.
לא יכול לשמוע את יוסי.
זה כלום לעומת מה שאני לא יכול לשמוע. תזכרו שאני חדש. Just remember, please, those who don't speak English. So you make noise. I'll never hear you.
What makes something famous if nobody here heard about it?
Okay, that's okay. Sure. All right, so this is Alexander Pushkin, the author of the famous story in verse, Yevgeny Onegin, and the reason it's relevant is because this is the object of what I think is the first study of transition probabilities, namely Markov chains. So the original work of Markov was to study the probability of two vowels appearing one after the other. It had to do something with notions of free will, whatever, but the basic, the empirical object of inquiry for Markov was Yevgeny Onegin. And this, in terms of work on language, opened the way for about 50 or 60 years, about 50 years of studies of transition probabilities and things of that kind in texts and in the way people understand texts. And up to the 1960s or so, it was by far the most dominant approach to psycholinguistics and the way we understand linguistic material. And this, as probably all of you know, gave way to a big success at the time of the Chomskyan framework, and the claim of Chomsky was quite the opposite in many respects. It's namely what governs our language in thought and symbolic systems. There's nothing probabilistic about them, or to the extent that there is something probabilistic, it has very little to do with language itself, but rather with mechanisms that implement language in use. And later on, I need not tell all of you, this was the advent of deep networks with people like Hinton, LeCun, and Benjo, the winners of the Turing Award, which paved the way to large language models. And here you can see one of the heroes. I don't know what his position is this week. These things keep changing, I'm told, but Ilya Sutskever is one of the most important driving forces, and the reason I bring him up here, first of all, is to give credit where it's due, and secondly, because I saw a video of his from a couple of weeks ago in which he said something like, to predict, this is not mine, to predict the next token well enough means that you understand the underlying reality that led to the creation of that token. I'm not sure I fully understand it because I don't know what the underlying reality, what one means by underlying reality, but the basic idea is that you really want to predict the next token in many respects in a way that was initially trodden by Markov and people who followed him. That's the basic idea. And the question is, do we want to use these models as a scientific theory of language? This is the question that I would like to address, and I'm happy to see that Ariel Goldstein is here. In fact, his work will feature in just a few slides, so Ariel not only has work that's relevant to this, but also he's the next ELSC speaker this coming Thursday. We didn't coordinate. Okay. So this is the most ridiculous background that you can imagine. and we can go and think about what it is that we want when we have a theory of any cognitive function. And I think what one needs are at least three components. One, you want to understand what the function is, namely what one means when one talks about language and speech, or speech, whatever. Secondly, you want to know something about the anatomical substrate at whatever level of description. And then you want to know how the physiology is implemented in the substrate so that it produces the function. That's what everybody wants. I mean, it's nothing controversial that I'm saying, nothing at all. And so if you look at the work on linguistic communication, there's at least one area in which there's been, I think, considerable progress towards achieving this type of goals. And this is the work with the word of speech. So here's what I would like to do. I'd like to give you a small example of physiological signatures of the basic building blocks of speech perception. Then I'm going to move to large language models and language in the brain, not speech, but language. I'm going to offer three critiques of this stuff as applied to neurolinguistics, some of which will relate directly to work by Uri Hasson and Ariel Goldstein. And then, if there's time, I'll mention an alternative. That's the plan. So let's talk about the physiology of speech. This is a paper that's done by, I think, an incredible group led by Eddie Chang at UC San Francisco. And the work they did here was to try to characterize to ask the question of, does the superior temporal gyrus encode phonetic information? The challenge is there's huge variability in the realization of phonemes depending on context, depending on speaker, depending on noise conditions and things of that type. And still, there is perceptual constancy of these objects. And for that, what they did is looking for some kind of phonetic generalization in the noisy auditory cortex. What they did was they created some kind of a basic recorded text that's 500 sentences, in fact, uttered by 400 different speakers. And this was natural speech. And the most important point, I think, is that it contained the complete phonemic inventory of English. Why do you want it to contain the complete phonemic inventory? Well, for the same reason that when you test a typewriter, nobody tests typewriters anymore, but it used to be that when you test a typewriter, you type a sentence that contains all the alphabet in English. So, I used to do these things. It's a famous sentence: the quick brown fox jumped over the lazy dog. And unless you type the whole sentence, you don't get to test all the keys. So by this logic, that's what they did, and they tested the complete phonemic inventory of English. And what they did is they used ECOG technique in patients that undergo neurosurgery for the removal of epileptic foci, and they set up some kind of a high-density multi-electrode array on the temporal lobe, and then they started getting some signal out of this extremely noisy stuff. And what they found is, first of all, these are specific electrodes aligned by different phonemes of English, and these are just happens to be 5 different electrodes. And you can see that if the metric is a metric of something that they call phonemic selectivity, phoneme selectivity index, which is something they constructed in order to see which is the most salient response that you do get some selectivity by phoneme in different electrodes. So there is variability, but it seems to be systematic. You get some clustering of something. Moreover, it's not just systematic, but rather you notice that something else is happening. Namely, these phonemes seem to cluster somehow. So it's not as if a particular electrode is sensitive to a single phoneme, rather it's sensitive to a group of phonemes. And it turns out that these phonemes are organized by what's called in phonology distinctive features. So the idea is that there's a feature matrix that characterizes each of the phonemes that we utter or that we perceive. And in fact, it seems, at least on this panel, it seems that they're clustered somehow by feature, namely there's some similarity to these phonemes and some similarity to these phonemes and so on and so forth. And to test it, what they did a hierarchical clustering technique. If I jumped too far, they used the hierarchical clustering. Wait a second. Oh, one word of caution, the anatomy here is very vague. Namely, you get to know what the electrodes are, but you don't get to know where they are. So we get no information about the location, the specific location of specific electrodes. We just don't know. All we know is that there is a matrix of electrodes that's here, somewhere around here. Yes?
This is a single subject. This is a single subject.
No. These are several subjects. Honestly, I didn't put in how many there were, but there were several subjects.
No, but not this one. The plot that you showed. The next slide. This is one.
This is from a single subject.
Yes, this is single.
Yes, this is from a single subject.
But they know
And
the
then-
relative distance between the different electrodes.
You think I hear you, huh?
I mean, they know the distance between the electrodes that they put. They know which electrodes are
Right, but
close.
they don't tell you. If you read the paper, you
It's
don't
right to
get-
the reader, not to them.
I suspect that had there been some generalization about the location of electrodes, they would have reported it.
But what do you mean by generalization across subjects, or within a subject you can say where the electrodes were?
Yeah, all I'm saying is that the anatomy as reported is very vague. That's all I'm saying.
So we have to go from the beginning. There are clusters here. They were organized in some way, which is not clear to me now after you spoke. You see, there is one on the top, one on the bottom. What is characterizing the one on the top?
This is what you see in the next slide. This is what you see in the next slide.
Okay.
And the point I'm making is that you don't have any information about the location of any of these electrodes on cortex. That's all.
But they know.
Of course they know, but they don't
did
report
the
it.
experiment.
But hold your horses for 1 second.
1 second, yes.
Yes, and then we'll see. The only point is
Refer
that
some
something like
sources.
okay, now you can see that they applied a hierarchical clustering technique to see if there's anything truly common. It's not just observation, just by some impressionistic observation, that there's something common to these. They applied hierarchical clustering techniques, and the clustering behaved very much like those phonemic features. Very much like it. And this, if you want, is an amazing miracle, because these are abstract features. These are not concrete phonemes, but are abstract features, like whether it's voiced or not voiced, whether it's something that's articulated by both lips or by the throat or something like this. These are abstract features that in fact are derived from the motor world rather than something that's perceptual. It has to do with something called the motor theory of speech perception, but we can leave this aside. The only point here is that there are abstract features which can actually be read off cortex directly. And the amazing thing is that these abstract features were proposed in the 1930s by two very famous linguists. One was called the Prince Nikolai Trubetskoy, and the other one was called Roman Jakobson, famous Russian linguist from the 1930s, who proposed this kind of theory. And in fact, the inventory of phonemes that was given to the subjects was derived by using this type of this typology. So this is to me, it was quite amazing that you could actually read abstract phonology out of cortex. And in fact, Eli and I at the time wrote a small commentary to this paper in Science, and we pointed out that 80 years later, you can actually read off abstract linguistic, like Trubetskoy and Jakobson would not have dreamt that somebody would actually poke a brain and find this kind of stuff. And that, I think, is quite amazing. With this in mind, okay, so this is like, I think, a major step towards realizing what we wanted earlier, namely we want some characterization of the cognitive function. And we want to get some information about how this cognitive function is realized. So with this in mind, I think we should proceed and see what's happening when you go to bigger pieces of language, namely sentences, texts, stories, whatever. And the basic logic that, yeah.
A clarification question. So this has to do with speech
Yes.
and not with written language.
Yes.
So
Speech.
It's important because the language models that we're going to talk about are text and not speech.
Not necessarily. Not necessarily. If you know how to convert things, not like these guys use auditory materials. Not necessarily.
Okay.
But the focus here, the units of analysis, the building blocks, or one second, the building blocks are phonological building blocks. That's the critical thing.
But this is in speech, not in text.
Right.
Do you think
Sure.
this is also true for text?
I'm not disagreeing with you. This is speech. I said this is just speech.
Which is
Why, you will mostly find that the next slide is an answer to your question. So just there with me.
In the last slide, the characteristic modulation of tone in when you change frequency is missing from those. Those are all changing pretty much intensity. And
Yes, but remember that this is a derived index of something which I didn't tell you much about, namely something that's called phonemic saliency, what do they call it? A phoneme selectivity index, which is like a highly derived index.
And that actually does not have much about managing frequency in it.
Not
Rising tones, falling
No.
tones. Okay.
No.
But people do use it.
It's speech, of course. Okay, so when you go a little bit, I don't know if higher, but whatever, you go to bigger pieces of perceived material, and it can be in written or spoken, whatever, the basic tool that the groups who do this use is they basically use pairwise correlations, fancy correlations, okay? But the idea is you look at some kind of behavioral scores, then you look at machine scores, large language model scores, and then you look at brain scores, and you look for correlations in some task. That's what you basically do. And I'm going to talk about two studies. One study is a study that was done at MIT by a group that's headed by Fedorenko. I think the first author is Martin Schmidt. The other one is Uri Hasson's lab, and this was Ariel. And I'm going to talk about these two studies very briefly. So here is Ariel's study. You take a text, and this is an auditory text, and at one point you ask your speakers to predict what the next item would be, and you get some kind of a score. You get lots of stickers. I think he used like 300 speakers from Amazon Turk or something like that. And then you do the same thing with a large language model, and the correlation is pretty good. And then the next step that you do, of course, is you go to electrodes that are placed, I think similar to what we saw before. You go to electrodes placed in patients, on patients' brains, and you look for correlations with the signal rather than with, you look for correlations with the signal, so you get all these like three types of sources of empirical stuff, and there were 160 electrodes with significant correlation at the peaked lag between predicted and actual word responses for semantic embeddings. Namely, you got very nice correlations. That's pretty good, okay? And then the claim goes, and I think Ariel will expand on it on Thursday, just looking at his abstract, that in fact this is empirical evidence that the human brain processes incoming speech similarly to an autoregressive deep learning. That's the idea. So this is work number one, and I'm just presenting it as it is. And just a small note of caution is that there's no real anatomy here. You can see it yourself. So these are the 160, the locations of the 160 electrodes. It's not very easy to know what kind of anatomical interpretation we can give it. I don't think this is anything controversial. Okay. The next set of studies is a set of studies by F. Fedorenko. I'm not going to go into the basic details, but the claim is that you hear semantically and syntactically diverse sentences, and basically the same exercise is done here. It's not quite accurate because in this case what you do is you actually use a subtraction technique. So typically you subtract non-word lists from sentences, but we'll get into this a little bit later. But basically the idea is again to present subjects with some kind of text. Sometimes it's written, sometimes it's auditory. And the idea is that you get the same kind of results no matter in what modality you do, and whether you look at fMRI or at ECOG, everything kind of converges on the same kind of thing, and the same kind of thing is, once again, in large areas. This is supposedly the Broca's area. I don't know how one can draw this like that, but supposedly this is Broca's area. But you get very large areas which extend to, you know, the supplementary motor area, I would imagine, and a lot of it in the temporal lobe. And once again, the claims is that you know, the GPT-2 consistently outperforms. They compared 43 different models, and GPT-2 was the winner, and it was quite amazing. And again, the anatomy here is quite vague, and the results are amazing successes. Both papers claim, you know, that this is serious evidence for the cognitive or biological and neurobiological relevance of large language models for language. You can see these papers have been quite successful. You know, Ariel has been cited, this is last week, almost 200 times. Ev's paper was cited over 200 times, so then it's pretty good. So this is the landscape, and again, I'm just using two, a little bit by way of caricature, but the basic logic that, as far as I've seen, is employed by this type of studies is what I showed you. So can we really be convinced that at least this is a beginning of some kind of a model for the implementation of language?
I have a question. Is there a claim about mechanisms or just
No,
about
no.
just about statistical ability, right?
Again, I don't know. You know, ask him on Thursday. He will tell you.
Please.
Okay. Ask him on Thursday. He will tell you. In these papers, I don't think there's really a claim on mechanism. I think there are hints and attempts towards the end, but I'd rather stay out of it. Okay. So now the question is, can we really be convinced that we're looking at something good? And there's several questions that we need to ask before that. Question number one is, if we look at those large language models, do they really characterize the language function that humans have? And so we have to look at how these models perform on language tasks. Second question is, do these papers actually use tests that properly probe the human language function? We have to look at, you know, what they did, and I didn't really tell you. And the third question is, can we get anything new? Did we learn anything new about brain-language relations? Well, you know, there's a history to this field, and you know, the results that need to be grappled with, and perhaps we might take it. So this is what I intend to do with the rest of the stuff. I can tell you, you know, not needing to give you, to leave you without breath. I'll tell you that I think that large language models don't deliver a theory of human language function at all. I think that these studies used impoverished benchmarks, which really diminished their value. And I think that much of the neurolinguistic record is left uncounted. So this is going to be basically the function. And let's go into some details of that. So what do you want your model to account for? What exactly does it mean that they don't deliver a theory of human language function? Well, take a look, you know. There are many kinds of things that we want our model to many kinds of properties that we want our models to have with respect to the empirical world. So one thing that gets, of course, a lot of visibility all over is this thing called Turing test, which I hope you all know is a nice idea, but it's an extremely vague test. Okay, it's not really a test. It's like, well, let's see if somebody can fool us. Okay, so we have the Turing test, conversation, and everybody knows that ChatGPT is amazing in this respect. Amazing. Okay. We also want things. We want to predict the next word. There's no question about that. This is what it's typically used, but there are many, many other things. And these other things need to be reflected on. So one of them is we want to see if it exhibits temporal and error patterns of language-dependent behavior, for instance. Okay, there's tons and tons of experiments for like 100 years perhaps about such patterns, and we want these machines to behave, for them to count as a scientific theory. We want them to account for this type of stuff. And again, it's a matter of taste, but to me, what's more important is that the kind of data that has been used for, I don't even know for how many years, to see human abilities in language in terms of judgments of well-formedness, judgments of meaning, judgments of plausibility, and things which have been used for a very, very long time, way before Chomsky, by the way, for those who abhor Chomsky for some reason. You would like these machines to also meet the kinds of requirements that one requires from linguistic theory. So this is just the rules of the game. If you use something new, you better show me how it works for things which you already know. And there's other stuff we want, hopefully, that the architecture, this has to do with Mirav's question, we want the architecture to fit something that we know about cognitive architecture, how it fits brain data and health and brain disease and so on and so forth. That's what we want. And again, I can't see how this would be controversial. And to cut a long story short, I can tell you that I think that these machines are doing quite well. I don't need to tell you, you know it yourselves. When it comes to the Turing test, it does quite well when we're talking about predicting the next incoming item. But when maybe it does a little bit on the third thing, but it does quite miserably when we look at the other functions. And this is something that we need to take seriously now. Kind of sadly, very few people have been, in fact, investigating it. So there have been a couple of labs, mostly one thing to remember, there have been critiques of large language models. And those critiques, mostly by Emily Bender, Timney Jebel, and people like this who have been claiming that, these machines are biased, they foster hate speech and racism and things like that. The reason, I have nothing intelligent to say, to add to what they're saying, but there's something important point. These kinds of behaviors that the machines are said to have are humanly possible.
Not just possible.
Sorry?
Not just possible, actually happening.
Yes, okay, so they actually happen. But the important thing is very sadly, they're within the realm of possibilities. Whereas the kinds of things that we're looking at are things that are not human. We're looking for the boundaries of what's humanly possible. So it's a different kind of critique. It comes from a different angle. Okay, so as I said, a couple of labs have actually been trying to set up some kind of benchmarks for linguistic behavior. I'm not going to get into any of the details. It's basically at NYU, Sam Bauman and Tal Lindsay have been looking at these kinds of things, and some other linguists like Roni Katzir, Nur Lan, and Emmanuel Shabla in Tel Aviv, and Ecole Normale in Paris have also been looking at it. I don't want to get into the details of it. I have all kinds of issues with it, but I think the easier way to your hearts and minds, I hope, would be to give you some examples. And the examples I want to give you are examples that are not just like something that I picked at random, but things which I think have some kind of a more profound value with respect to testing these kinds of machines. And I'm going to look at two types. One, where these machines are a bit like bulldozers, and they're just too strong. And it's not obvious to me at all how this can be weakened. But more importantly, places where they're too weak, maybe they fail quite miserably, where we succeed quite quickly. Okay, and again, it's really a tiny sample. All right, so one thing which I think I showed this group before is this business of syntactic complexity, the level of embedding. These are metrics that have been used since the late 1950s in the University of Chicago. You know, you can embed, you can say the man left, you can say the man who the woman loves left, but when you say the man who the woman who the girl met loves left, it's not easy to understand, and the claim is that there is a piece here which is embedded too much, over-embedded, and that makes the sentence humanly unparsable. So just as an opening, I tested this machine, same thing, okay? So I tested this machine with 4 such embeddings, and it did beautifully. It really did beautifully. You know, you can look at it later. I don't want to go through the whole thing, but let's look at the sentence like, I say the man, who the woman, who the boy, whom the girl pushed, saw, hugged, fell. Tell me who fell and who saw. And it does pretty well. It kind of peels it off like an onion, and it does pretty well. It's not the hardest thing on earth, but it shows you, you know, that this is really a good bulldozer. Okay, we fail on this. Again, it even summarizes very nicely what really happened after it analyzes and so on. So now we move to instances in which this machine fails, and the first thing to look at, because you know everything there is based on rank ordering, the first thing to look at are ambiguities. Yes?
You're saying that we fail on this, on the previous example, but we don't. I mean, we have to look at it analytically, and then we match.
This you can use.
This is not like mixed world completion, right? It's not. We're using human ChatGPT as something.
I'm not sure I understand the question.
I mean, when humans think about that example, they don't fail. You mean that it's not parsed as grammatical for humans, right? I mean, there's no indication that ChatGPT found it to be grammatical, right? It just realized what the structure is.
You need a theory that will determine what's grammatical and what's not grammatical.
That's not what you asked.
No, I said humans fail on one, and this machine succeeds. That's what I said. I didn't bring in a theory. I kind of hinted at the theory. You're right, I'm sorry. I hinted at the theory, and I said, if you have triple embedding, you collapse.
Yeah.
That's just some kind of a descriptive observation. The source of the failure is not something that I actually made a big deal.
But your ground truth is human.
What?
Yossi, your ground truth is human. So your ground truth is human. So something in the logic here is a bit inconsistent.
What about the logic? Tell me.
If you're saying the machine succeeded, it means that you're evaluating it based on, you can decode what the sentence means and then evaluate the machine managed to succeed. So by definition,
absolutely.
Succeeded.
I completely agree. You can also, in a minute you'll see, you can also decode ungrammatical sentences. You can recover their meanings. And sometimes this is a unique meaning. And the question is, do we get this meaning? In fact, the next example is going to be exactly that. Humans get 2 meanings, and the machine only gets 1.
No, but that's not an answer. When you say human, the answer what you mean. If you give it an exercise and enough time for a human will not be able to pass it.
There's about 1,000 articles that show it in like 1,000 different ways, that when you give it to humans, they collapse. Now, if you give it to them as a whole exercise, wait, so how do you know what the ground truth is? This was Ami's question.
Yes, but I didn't give an answer.
No, there's no, because the reason I'm not answering here is because in all truth, I don't think it's a grammatical issue. Okay, I think it's something having to do with the way grammars are implemented. There are formal reasons to believe that this, is, in fact, is a grammatically possible sentence. It just cannot be implemented in humans. And the only reason I'm giving it here is in order to show you that, you know, brute force sometimes can be too much. That's the goal here. So I'm not exactly avoiding your question, but I refuse to answer it in a...
Don't avoid, but you refuse to answer.
No, I refuse to answer it by giving... No. Avoiding is avoiding. Avoiding is what you see in press conferences. Here, I refuse to answer explicitly, and I give you a reason for why I refuse. There's a difference.
But okay, that's the reason.
Okay. So let me just, let me move to the next one, perhaps you'll understand that. So there are very famous ambiguities which you can see in noun phrases, like here, like the first board member. And the question is it the first member of the board, or is it the member of the first board? A member of the first board. So this is a classical ambiguity that has really nothing to do with generative grammar. These things have been known forever. In Hebrew, when I was an undergraduate at this university, structuralist, anti-Chomsky linguistics, they had examples like Chaverat HaKnesset HaRishona. I think this is where I took it from. It's very nice to see. And what I did was I asked ChatGPT, is this sentence ambiguous? And it said yes, but the ambiguity detected had nothing to do, I don't even know it's an ambiguity, but let's forget about this. The ambiguity is detected in what sense this guy is first. It never detected this meaning at all, namely of the list of meanings that it gave you, none of them mentions that in fact there's a series of boards and we're talking about the first in the series. And this is a or the member of that series. So it fails to detect this kind of ambiguity. This is an example of a case in which it's difficult to argue that we don't get both meanings. We do get them. And this machine doesn't get one. And
Yosef, so do you think that statistically that means that since ChatGPT is built on a large database, that statistically the first meaning is more plausible or more occurrent than the second?
That's possible. If you start,
that's what I would understand.
Yes, but again, it depends. That is likely. The question is, if it occurs first, is it the first to come to mind? Okay. So there's something that's called the more salient reading and so on. I investigated it just a little bit. I kind of skirted around it, and I don't think this is actually true. Because in fact, when you think about it, the first meaning that should be there is this meaning. And the reason is because, in fact, there's some kind of an adjacency that you get. Yes, John?
But it's not if it was regarded as ambiguous or it has a problem with introspection. If you would ask him a direct question, or if you embed this sentence in a paragraph, would you be able to understand it?
In most cases, in some rare cases, yes. That's good. In some rare cases, yes. But then the question is, what does it teach you? I'm not sure. In some cases, yes. In other cases, less.
Is a claim
about
introspection?
No, but again, the claim, it depends on what you take this machine to be.
In building the data set, the large data set that the large language model comes from, are those two cases labeled in such a way that they can be distinguished?
The answer is I wouldn't be able to tell you. I just don't know.
I suspect not.
Well, okay.
Because you just pour it in.
I don't quite know, because typically, again, the little I know about labeling, what you label, you don't label phrases, you label words. So if you label words, they have the same label. That's the point. The point here is this is what's known in syntax as structural ambiguity.
Yeah, in many cases they boil it actually down.
Yes, so here you can see this is a clear case of structural ambiguity. The question is who clusters with who. So the labeling at the word level would not solve your problem. Okay. Here's another case, and this case is a little bit more subtle because it's an ambiguity that has to do with scope, a relative scope of two quantifiers. So if you say a girl spoke to every boy, there are two interpretations to this sentence. One entails there being a single verb, and the other one entails there may be one or more than one. Okay, so maybe there's like a pairing for each girl. As you can see here, there's a girl such that for every boy, this girl spoke to a boy, and to some boy. And the other one is in which there's what we call inverse scope, in which, for every boy, there was a girl such that she spoke to him. And these are two meanings, and these meanings are easy to identify. And I asked the machine, well, what happens? And it was very clear that there was one girl.
Does it depend on the previous sentence? The previous sentence says there
I
were
don't know,
20
maybe.
boys and 20 girls.
That's possible, but the question is, what exactly are you looking at? You know, the machine's ability to integrate text, so you want it to behave. Remember, the claim is that it's human. That's the claim I'm up against. The claim is not whether this machine can do stuff. It can do amazing stuff. The claim is, what its status is when we're looking at it as the model for human language. And for humans, the main point here is not to conflate variables. We mentioned, this question came up earlier by Jonathan. Okay, how does context help? This is what I should have answered actually. Maybe it helps in some cases. But the thing is, this is not what we're after.
But when I read this sentence, I couldn't see two meanings. But then I said,
That's
okay,
it.
there are two
Of
meanings.
course,
What
of
could
course,
be
of
the
course.
second meaning?
One meaning is more accessible and the other one isn't. It's exactly the point that I think Leo made. It's exactly the point. Sure, of course there are such instances in which one meaning is more salient. No question. There are lots of debates whether it has to do
To comment
with
with what Prof said, I also had this, but I noticed that my brain somehow ignored the a girl spoke, and I thought, well, in English you say the girl spoke, and then I converted the
In
meaning.
Hebrew, it's a little. In Hebrew, there are no indefinites. There are all kinds of issues with Hebrew, but it doesn't really matter. The basic idea here is that, you know, there are two quantifiers, and because they're not the same, there's a meaning for the relative, the scope of one relative to the other. And there are many issues here. For instance, some people think that it's always easier to process the one in which the order of quantifiers and the logical representation is the same, is congruent with the order of quantifiers in the sentence. It's not always true, as it happens. Yes?
So there seems to be consensus that the ChatGPT's answer is most of us will come to mind with the first interpretation. You're right that there are more than one. But you didn't ask in this case, is there any ambiguity?
Didn't I tell you to wait for the next slide? Every time, just think about it. How about this? Exactly, just think about it.
Since the definition of
I have you in mind when you do
You
this.
have to check me.
I have time specifically in mind. So, that's,
Maybe it's a final question. If you wrote down all your criticism text, feed it to ChatGPT, then ask it.
I should do it. Maybe you should feed the whole lecture.
Just your criticism, then ask it on a different example.
Yeah, okay. Okay, so this is excluded. And then I said, but is it possible that there was more than one girl who spoke the book? And the answer is no. I mean, again, they never give you these conclusive, there's some hack there that never gives you very conclusive answers. But you can judge for yourselves, you know.
You ask, is it possible, and it answers you, it is understood. It doesn't answer whether it is possible.
It never answers. One thing that you see is that when it comes to these kinds of junctures, it never really answers. There's some hack there that puts vagueness. But you know, it's most logical to conclude that there was just one girl speaker in this scenario.
It's communication. Why 5 words? Why does it make up a number for the number of boys? Like out of nowhere.
No.
I think in the previous one I said, in the previous one I said there were 5 boys, just to make sure that there is a plurality. So, yeah, anyway. Okay, so here's another case, and this is an important case, and the case here is you look at sentences that have an ellipsis, a missing piece, and the question is, what is it that you complete in it? This is like a very central trick in syntax semantics. So one thing that's quite amazing is that you look at such a sentence, John walked his dog and so did Bill and Mary. Okay? And one thing that you know about it is that it has 2 meanings. So if you ask, is it ambiguous? Well, humans identify 2 meanings. For each listed individual, X, like John, Mary, and Bill, X who walked the dog, X walked his or her own dog. So here the pronoun is actually a variable, so it says whoever is the local mentioned guy, antecedent that we call it, this would be it. So this corresponds pretty much to this ridiculous picture that I've got off the web. 3 dogs, 3 humans. But there's another meaning here. And the other meaning here is that everyone walked John's dog. There's just one dog. Okay? Well, you ask ChatGPT, and they give you exactly what you want. Beautiful. This is beautiful. Gives you both meanings.
But there's a third meaning. John walked one dog, and Mary and Peter walked another.
No, that's not a possible meaning in English, unfortunately. But thank you for thinking about it, because this is exactly the next slide. Sorry. This is not a possible meaning in English or Hebrew. Okay, it's not. No matter how much you force yourselves to it, it's not a possible meaning. And given that it's not a possible meaning, again, I can walk you through several proofs. I can, or Neil can, anyone who studied some syntax semantics can do this kind of trick, convince you that this is not a possible meaning in English.
But it's a possible interpretation of a human, right? When we just saw it.
A possible meaning for a native speaker of English. That's what you mean by possible meaning. Okay? And here, the machine actually not only accepts this meaning, but also apologizes. Okay.
Saying that it's not what
saying it was wrong by neglecting this additional meaning. So you can see there's probably a lot of hacks here that ease the interface with the user, but that's beside it. Okay. So this is the $20 that you made me pay. Okay. This actually works. This is GPT 3.5, but it works for GPT 4. This thing was challenged, and I ended up, on Jonathan's advice, paying $20 to meet the challenge on ChatGPT, GPT 4. Okay. I just want to point out one small little detail about humans, namely this kind of complex construction, namely ellipsis of this type, John did blah, and so did big, is something that you know when you're 3.5. So this is texts between exchanges. There's a big database of exchanges between family members and children. It's been sitting there for many years, and we did some search on it quite a long time ago to see how early are kids able to emit these types of sentences, and the answer is between 3 and 4. It's pretty good. They will not get these kinds of things, namely with the pronouns. The combination between the deletion of a piece of a sentence and the pronoun is much more complex. But at least the basic VP ellipsis, namely the deletion of a piece of a sentence like this, is something that they get in 3. And when you start doing the calculations, I didn't do it accurately, nobody can do it, but Gary Marcus has done it several years ago. The proportion between the kinds of sentences, the number of sentences that children get at the relevant age and the number of sentences that these machines need in order to work is like staggering. Just a little point. Okay. Let's go back to Ariel's study, okay, with all this in our pocket. And one thing that you notice is something I didn't give you before, namely, what text did they use? And they used a lovely text that, in fact, is taken from This American Life. I don't know how many of you know This American Life. So this is a very funny thing. It's called Monkey in the Middle. Okay, monkey and a horse walking through a bar. It's a very funny text, and they cleaned it up in particular ways for noise, and they had the people listen to it. The question is, what does this tell us about human language? And the problem is that I don't think it tells you much, because there's none of the syntactic and semantic complexities that make us human you can find there. No ellipsis, hardly any negation, quantifiers, any questions. You don't really see this. And most importantly, nothing is weighted. It's just some kind of a text. It's a nice text, it's a lovely text, but it's a text. Now this stems from an ideology. It's not something that's there out of negligence. And the ideology is that the way to do this is in the wild. Namely, the only way to do this type of science is to actually harvest things as they are, to to record people talking at the cafeteria or whatever. I find it very difficult to accept. I don't want to argue with it. I find it very difficult to accept because this is not a way to get an idea of what of the way of people's knowledge. It's very much like the thing I told you before about the typewriter. If you want to test a typewriter, you have to test all the keys. And here the impression is that it's a little bit like Jack Nicholson's typewriter in the movie The Shining. I don't know if you know this. He's sitting the whole movie. It's like a horror film, and he's writing a book. And at the end, it turns out that he takes one sentence: "All work and no play makes Jack a dull boy," and it just contains a single sentence. And to me, what this type of work does is very much like the Shining, because you don't get a sample of things. It's like the analog for the speech study would be to record somebody saying ba 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 ba, and then making conclusions about language. It's very difficult for me to see how you can draw conclusions about language from something like this. And very similar criticism with a little bit more detail applies to the work by Efta Durango. She constructed a text which she claims that is semantically and syntactically diverse, but this is simply not true. I went through every single file of her stimuli, and it's simply not true. It has sentences that are picked from something which all have 12 words. The control for it, namely the control condition which is actually subtracted, also has 12 words or something like this. There's no control, there's no syntactic variety, hardly any syntactic variety, just like before. And in fact, here it's even worse because there's no control for word length, no control for morphology, no control for neurology, for phonology, things like that. Nothing. So it's not at all clear what you capture when you do this kind of stuff. And so, you know, we can conclude quite sadly, I think, is that when it comes to the function, these guys don't deliver an account of human linguistic ability. When it comes to the functional tests, they're quite arbitrary. And finally, the anatomical subtraits are rather vague. Again, I didn't go into the details of it, but you know, really for want of time. And I think this is the functional issues, the linguistic issues are the ones that are more important to emphasize. I'll finish in like 2 minutes.
So you would, I get the sense that you don't think that human language is strictly algorithmic, that maybe 90% of it could be accounted for in an algorithmic way, and then the edge cases are a place where if you approach it algorithmically, you're bound to fail. Is that kind of the underlying hypothesis?
Yes, in a sense, yes, but frankly, I don't see how it's relevant to what I said. In a sense, you're right. This is, of course, I don't know if it's 90% or 60%. I don't know. But the thing is, my personal opinions are really not relevant here. Okay, what's relevant is that you use the same logic that these groups use. Namely, you look at the properties, the linguistic properties of the materials at issue, and you look at the selection of test cases. It's not as if I challenge anything like the basic logic that underlies these endeavors. What I challenge is how language is looked at. And the claim is that language is looked at the way these groups work deliberately. I mean, in the case of Yosef Grodzinsky, it's a different story, but in the case of the Chasson group, and at the end, this is deliberate. It's not something that is done just out of negligence. You know, and I'm saying it in due respect. It's deliberate, and I think it's completely wrong. And I hope that I showed you that there's something deeply wrong about it. Okay.
But you say, following up to this question, suppose it works well in the 90%, which are more probable cases, but doesn't, whatever, some other small percentage. Do you think this failure indicates different underlying mechanisms?
Well, one thing we can ask yourself, suppose you compare, and I've done so you compare GPT-3 with GPT-4. And you realize that yes, there are quite a few cases in which GPT-4 works better than GPT-3. Not a big surprise, it does. And then you ask yourself, so what did I understand? What did I understand out of it? And the answer is not much. All I can say is that they use bigger texts. They have something fancy in their networks that they admittedly don't understand themselves. That seems to be the
That's a different critique.
I'm sorry?
That is a different critique than the one you listed. Because if, let's say, ChatGPT 10 would do correct and rectify all the things that you mentioned here, you still can say, what does it mean? How do I understand? The interpretability is not one of the criticisms that you have in your list.
I completely agree with you. We had this debate on eBay a few months ago. No, I agree with you. There are two different kinds of critique that one might invoke. And the critique that these kinds of heavy machinery does not necessarily lead to understanding is something that's sitting in the background all the time. It's sufficient, though, at any point in time, you use whatever is available. And it's sufficient for me to take a look at these and see whether there's any understanding. And the only thing that I ask you to believe me is that the cases I've given you are really indices of something that's a little bit more profound. You can kind of guess because they have to do with variables, and when things have to do with variables, then there must be some generalization of the relationship between these variables and something that binds them or something like that. So the things which are a little bit more profound than just this accidental example. So, the question really here is a question of understanding and not a question of implementation. You can implement things to your heart's delight. That would be the last challenge that I used GPT to. Okay. In fact, I wanted to use for the pictures of the dogs, I wanted to use Midjourney, but I was too lazy to get into it. Because you try 10 times until you succeed. So I'm not denying it's a fantastic technology, but it's not the same. For all we know, we have no tools to argue that this is scientific theory. You hear the opposite on Thursday.
It's difficult. You may be right, but you started with a list of implementations, and now you are diverting the discussion into understanding.
No, you were diverting the discussion. I didn't divert the discussion.
Okay.
No, honestly, but that's okay.
You answer by understanding. This is your answer.
No, I'm not answering by understanding. I'm saying to you this. There are two levels of discussion that you might have. First of all, is what the performance is like. And secondly, and that was what I focused on. Exactly. Okay, that was my focus. And then secondly, since you drew me to such discussion, I can tell you, it's not even if tomorrow there would be, like in GPT-N, there would be some success. The burden is on whoever constructed GPT-N to tell me why there's been progress. I don't think that there's any debate between us on
just want to play for fun.
I just wanted to ask if you took as your subject, instead of GPT and a human, two different humans.
Two different humans?
Two humans who speak the same.
So now the implication is that I'm a terrible experiment.
Now they will have different.
Okay, so
they
now
will have different interpretations. What will happen?
See, but GPT-3 and 4, they have underlying different structure than most LLMs, but they're a little bit different. And they practice on that. And at some point, they might kind of generalize differently than humans and so on. But so it's very possible that at some point, and we know also that in language we also do bad generalization and we also learn outliers. So there are like, go when it's like it's not obvious derivation of past tense, right? So part of the process is actually fit the model and then learn some outliers. And this is what they do, and maybe it's just kind of finding the perfect structure that will kind of will practice on and smaller text just like humans do and fit.
I'll tell you two things about it. First of all, the cases that I brought up are very far from go and went. It's really, there's no comparison.
But it's a
no, there's no comparison, and take my word for it as somebody who spent the past 40 years on this. No, these are deep generalization. Go and went is an exception. And it's an exception because it doesn't fall under any known generalization. And these are good representatives of deep generalization. This is why they were chosen. To you, it seems like some kind of arbitrary choice, but it's not. Secondly, and that's a rhetorical thing, everybody says, well, sometime in the future. No, we live on the 31st of December, 2023, unfortunately. And that's it. So, don't give me promissory notes, show me the money.
Show you the money. People use these very effectively and they understand the
But I'm not challenging, again, you have to remember, I'm not challenging it as a technology. I'm not challenging it as a, it's a fantastic technology. The question is, does technology, and we had this debate a few months ago, Nikki and Idan and Chaim and David Ben-Meruyev, I never know how to pronounce his name. Okay, I'm not challenging the technology. I don't know anything about technology. I wish I knew. This is amazing.
Functional.
The question is it a scientific theory? And the answer is no.
No, it is.
Yes.
Suppose there is QBT-X that is perfect, which is perfect. It meets all your criteria, every test that you give it gives the right answer.
Mm-hmm.
It still doesn't necessarily reflect the way the human brain produces language, right?
I don't. It doesn't necessarily. Yes. The question is exactly in the necessarily. May. But we need evidence to be convinced. It's a fantastic step.
What would be the question is what would be the evidence? Because this is like a functionalism. You mentioned bulldozers, right? So a stone can be moved from one place to the other. I can pick it up with my hands and move it, or a bulldozer can come and pick up the same stone if it's moved. Keep it up, and then you see the stone has been moved. And you say, look at the bulldozers, and then you conclude, this is probably how humans do it as well, right? They have engines and they have pivots and stuff. Of course, this is wrong, right? So this is the case with all kinds of these functional analogies. If you create a machine that perfectly mimics what the human is doing, the human brain is doing, what the human psychology is doing, it's still not proof that it's doing the same thing. So I'm asking for you, what would be good evidence that this is really a good model for how the brain is doing it. The fact that the large language models can pick up a lot, 90%, 95%, a lot of what language does in human life, I think is proven, right? Is it a good model for the way the brain is doing it? I'm saying that your critique is interesting. I mean, you picked up interesting examples of how it doesn't perfectly do it, but even if you didn't find those, you would still say the same.
No, I have a much weaker basis because for that I would need to, in a sense, I agree with you, because the problem that people like us have is that, when we're this minority, we always have to answer questions like, what if? It's exactly like Nikki, what if? Okay. And the thing is, no, but I do agree with you. Yeah, I do agree with you. It's incumbent on me. It would be incumbent on me and people of my dubious type to come up and see whether the explanatory structure that these theories offers is right or wrong. But here it's easy in a sense, and the reason it's easy is because the culture, it's like a sociological analysis for like half a penny's worth. The culture has been in this community. The culture has been that linguistics is not relevant, and I so never even look at it. And I can tell you, I saw some lecture last week, I think, by Jeff Hinton from about 5 or 6 years ago, and he said at the end, he said, there's one counterexample for which it doesn't work, and he mentioned the sentence, and he said. This is called the Winograd sentence. So the Winograd sentence is a sentence that's taken out of Terry Winograd's dissertation from 1969 or something like this. So somebody dredged up a sentence from Terry Winograd's dissertation and showed that in fact she got it wrong. This is not a methodology. And he said that it was laughing. Okay, I would be the last to say that Jeff Hinton is not a serious man. He's extremely serious. But there's something about the culture there that never takes this type of stuff into consideration at all. And this is a shame because the considerations come in two varieties. One are direct theoretical considerations with empirical implications, which are never even internalized by these people, by this culture. It's people. It's a whole culture. And the second one, you can benefit theoretically out of it. I'm not against machine learning, not at all. I think there could be fantastic combinations. I'm not against it at all. I'm just saying that there are clear limitations, and it's too irresponsible to just dismiss everything we know about language because these machines are fantastic. Let me show you the alternative, just like in one quick bite, that's all. So, this is like slowing down. I'll do it quickly because most of you have seen or heard it before, but the basic idea is to look at the brain not as just some kind of a nebulous thing with those huge areas, but actually divide it into smaller pieces. The pieces the method that I happen to have chosen, and there are reasons for this choice, it's not arbitrary, is to look at cytoarchitectonic maps. We have problems with these maps, which I can give you a lecture about from now to the afternoon. But the thing is, this is a choice that's explicit and that has reasons behind it. So the idea is that you have anatomical pieces and then you have linguistic pieces. And the project is aligning the linguistic pieces as dictated by linguistic theory to the anatomical pieces. It's not going to give me a full-fledged theory, but it's a start. And in fact, it's a start that gets support for the past almost 150 years, actually more, since Broca. It seems that there are actually selectivity. There is selectivity along syntactic, perhaps along semantic lines, and that this selectivity aligns with well-described designated brain areas. I've been involved in such projects for several years. Okay, we do this, we clean up all kinds of other people's data, we find things of a particular kind clustered in particular areas and not others. This is the project. Okay, maybe it's not the most exciting to you, it's not going to end up with some piece of software, but this is science. That's all. So this is all I can conclude, is that the majority view hasn't delivered, and of course, none of the results of the type that you see in this idea of the linguistic brain is an anatomical mosaic. None of the results are accounted for by any of these models. It's just, there's nothing that makes a connection. So there's a lot of data out there that is left unaccounted for. It's like thrown out of the window, and it's just not paid attention to. I'm towards the end of my career, so see if I care, in a sense. But I think it's just too bad. Anyway, so just in conclusion, the majority view hasn't really delivered something that's adequate, and the minority view is one that looks at this mosaic. And the one thing to remember is that, vox populi is not always the voice of reason. Okay. I've been in minorities in just about everything throughout my life. Might as well stay there. Thank you.
I have a comment and a question. The first comment is that I think it is very true, and even I would go further and say it's detrimental because it gives. A friend of mine said that deep learning encourages ignorance. And what happens, and this is basically what you're showing that this happens, and this is unfortunate. Because basically people say, we don't need the linguistic learning to really understand, just put it in the machine, it does it, and that's the end of it. And who cares if it's a theory or not a theory? Unfortunately, that's the vox populis. And of course there is now. On the more positive side, knowing this limitation as a linguist, as a professional linguist and researcher, is there something that you could use that would help you do better the understanding and the research, not the way everybody's doing it, but this is an amazing tool. How do you use it to get a better understanding of language in different ways than they're doing?
It's a great question, and personally I haven't thought about it. There's a very, very small group, a group between collaboration between Tel Aviv and Cordova, trying to think about it a little bit. I haven't done it. But I want to mention one thing about ignorance. And This is an article that was published in Haaretz on November 2nd. It was written by a historian of the failure in 1973, Uri Bar Yosef, who was a serious historian of this stuff. And he tells things about the failure here and the failure there. It's already November. And in the end, it ends by saying this. It says, 2 months ago, it was 50 years to Yom Kippur. 2 months ago, I was invited to give a lecture in Amman, in the military intelligence, about the failure in 1973. And I was in a panel where there were two lectures. One was mine, who talked about, psychological and all kinds of problems that hindered people from drawing the right conclusions, being led into surprise. And the second guy was a guy who built some kind of a large language model that supposedly predicted the results given certain kinds of input. And then he said, at the end of the panel, there was a question period. Everybody went to the large language models. I didn't get a single question. And he says, looking at that, I thought that I was looking at the beginning of, at the first buds of the next failure. Unfortunately, I had no idea that it would come so quickly. I don't need to convince anybody of this, but I completely agree. And I think this is to some extent what's happening here, so far with no tragic consequences. Yes?
How does ChatGPT go on problems where there's a single word which can have double meaning? I'll give an example. Bibi said to Gantz, "Why weren't you at the last press conference?" And he answered, "If I had known it was the last one, I would have come."
I had a friend who said if I knew I'd lived so long, I'd take better care of my head. It's the same kind of idea. But yeah, actually, the example that the Winograd sentence that Jeff Hinton gave had this kind of lexical ambiguity. It was something like the blocks. I can't reconstruct it, but it had to do with the reference. Wait, I have it. Wait, I actually have it in the computer. Because I actually tried. 1 second.
If the trophy didn't fit in the box because it was too big, right?
Yeah, but I actually have it with the response of GPT. No. Sorry. Here. Okay, so here is a sentence. Oh, right. Here, I don't know if you can see it, but it says the trophy would not fit into the suitcase because it was too big. The word is, so I asked it, the trophy wouldn't fit into the suitcase because it's too big. And then it says it refers to the trophy. And then it looks at the trophy wouldn't fit into the suitcase because it was too small. What does the word it refer to? And then it says it refers to the suitcase. So this is an example of, it's not exactly lexical ambiguity, but it's actually an issue of picking up the right antecedent, and it does successfully, much, I hope, to the joy of Jeff Hinton. Thank you. בסדר גמור.